These are your 4-7A notes. We're going to analyze graphs of quadratic functions. We did a little bit of this in the beginning of the year where we talked about the transformations of graphs, but we're going to do it more in terms of quadratics today. What I would suggest is maybe a couple colored pencils, but even better, since you have the note sheet, maybe 3 different highlighters. So if you can see on my note sheet, or on the screen, I have red, blue, and green. It will help if you color coordinate your different, the words in the description with the graph. So if you want to pause this, grab some highlighters, that would be great. So we're going to talk about this new form, and this is the second form for quadratics. So a quadratic, we know standard form. Standard form is y equals ax squared plus bx plus c. Okay, and then now what we did is we have a new form that brings in h and k. And you're going to see h and k showing up quite a bit. H and k is the vertex of the actual parabola. So that's why they call it the vertex form. Remember when we studied lines, we had 3 different forms of lines. We had y equals mx plus b, which was slope-intercept form because you saw the slope and the y-intercept. We had ax plus by equals c. That was standard form. And then we had point slope form, which was y minus y is equal to m times x minus x. And within that form, you had a point and slope. So in lines, we had 3 different ways to name a line. In quadratics, we have 2. So we have standard form that we studied already, and now we're introducing vertex form. So it's a little bit different. Y is equal to a times the quantity x minus h squared plus k. So I'm going to talk about what h and k do and what the a value does when it's written in this form. So in vertex form, your h is your horizontal translation. And we talked about this before, so this should be a little bit of review. The h number moves it to the left and to the right. So if you'd like, if you want to, the standard form, when h is equal to 0, that means we didn't shift at all. When h is equal to 0 is my blue graph. So if you just want to leave that one black, I think that would probably be the best way. So you really only need 2 highlighters. If the h units it goes to the right, h units, if h is positive. Now, the problem with that, when h is positive, it's really going to look like it's negative. So we talked about this whole opposite thing inside the parentheses. Even though the true value of h will be positive, it's going to look negative. So this is your red graph here. So if you have a highlighter, I would highlight this statement here in one color and highlight the red graph in that same color so that you understand that those 2 statements are combined. In addition, I would like to put a x minus, in this particular case, 2 squared. If you look at the red graph, it shifted 2 units to the right, even though in the parentheses it looks like a negative 2. It's really a positive 2 that I replaced h with. And so then the other graph, notice I put the absolute value. We really don't care about the sign, but the sign, if it's negative, it's going to shift to the left that many units. And so this next statement is for the green graph. And so if you want to highlight that in a different color that represents the green graph and then highlight the green graph. So that's when h is negative. It looks like it shifted 2 to the left on the graph, so that would look in the form of x plus 2 squared. Because really, when I plug in a negative and I subtract a negative, it turns into a positive. So h determines a horizontal translation. I like to play on words, h and horizontal. So then k is our vertical translation, vertical. I kind of play on the c and the k. They both make the same sound. So the vertical translation is true to the sign. So again, my blue graph is the parent function. And if it's a positive k, then it's going to go up k units. And so this one I would highlight in the red, just like we did before, and then have the same marker for the red graph below. and it looks like it shifted up 2 units. So this would actually be of the form y is equal to x squared plus 2, or y is equal to the quantity x minus 0 squared plus 2. A lot of times they won't write x minus 0 squared. You may have to write that. But when you're missing the quantity, that just means that the h value was 0. And then the green graph shifted down 2 units. And so the green is when the k value is negative. And so that equation for the green graph would be y equals x squared minus 2. Or if you want to, x minus 0 squared minus 2. So that's telling you that it didn't shift to the left or to the right any. It only went down 2 units. Oh. And then the red went up 2 units. So those are our h and k values. H shifts us left and right. K shifts us up and down. The a value does 2 things, just like a does 2 things in lines. It determines the direction of the line and it determines the steepness of the line. The a value in quadratics pretty much does the same thing. It's a sort of slope. Okay, so a, one thing it does is it flips my graph. So if a is positive, if a is greater than 0, the graph opens up, and we already knew this from the standard form. And if a is less than 0, the graph opens down. So if you want to highlight those in 2 different colors to match, my up graph is because a was greater than 0, and then my upside down graph, my red graph, is when it's less than 0. Okay, and that's a reflection. So we want to bring in that terminology of reflections, translations. And then this last part, A also affects the dilation of the graph. So this is where we're going to talk about stretching and compressing the graph. So notice we have absolute value signs around the A value because we don't care if it's 3 or if it's negative 3. If it's greater than 1, the absolute value is greater than 1, it's going to stretch the graph vertically. And if it's something between 0 and 1, like a fraction, it's going to compress the graph vertically. Remember we talked about compressing is when we sit on it, it's going to get fatter. And stretching it, we're pulling it up, it's going to get skinnier. So again, with your highlighters, if you want to talk about the first part, the stretched vertically, this is your red graph on my screen. The blue is when A is equal to 1, so that's your parent function. And then the green represents the graph is compressed vertically when we have a proper fraction. So the green may be like 1/3 when A is equal to 1/3, where the red may mean when A is equal to 3, if you want some values like numbers. If it was a negative 3, it would be the same width, but just upside down. So it would match that same graph. So today we're just kind of getting used to that form and then being able to pick out all this information. Before we even graph it, we should be able to tell what it's like compared to the parent. Okay, so vertex form is of the form, one more time, y equals a times x minus h squared plus k. When a quadratic is given in vertex form, we can't really see the y-intercept anymore. There is no c value, but what we are staring at is the actual vertex. If the h coordinate, the h number shifts us to the left and to the right, and the k shifts us up and down, we are staring at our vertex. Our vertex of that quadratic is hk. So we don't have to find the vertex. When it's in vertex form, it gives us the vertex. And then the axis of symmetry goes right through the vertex. So the axis of symmetry is the equation x equals the h value. They have to line up together. So it gives us a little bit different parts than what standard form would give us. So let's look at these problems here. And we're going to describe the following functions in terms of position, direction of opening, and width compared to its parent. So in number 1, it's a lot of writing. We're going to use our mathematical terms. So let's talk about this -2. That -2 is going to stretch the graph vertically. The negative part of that 2 is going to reflect the graph, the parent, over the x-axis. So the parent is reflected over the x-axis. Whenever you talk about a reflection, you got to tell me that it's reflected and where? Over the x-axis. It's going to go down. It is stretched vertically. Because of that negative 2. And then it translates. It's going to translate two ways. It's going to translate 1 unit to the left because the H value is actually a -1, and 3 units down. Remember, when we talk about translating, we have to say translates. We have to say how much, so the units, and then which direction, up, down, left, or right. And there you have it. We could actually also say that we have a vertex of -1, -3. Okay, and then we could also say that the axis of symmetry is the equation x equals -1. Just by looking at the equation, I have not done any calculating to graph anything. I can just describe it. If you look at number 2 here, okay, in number 2, my A value is less than 1. It's positive, so we don't have a reflection, but it's less than 1, so the parent is going to be compressed vertically. The parent graph is compressed vertically. And this -3 here inside is my H value, so that's a translated, and it's translated 3 units to the right. That's really a positive H value in there. Looks like a negative. The K value here is +0, so we really don't have to mention that, but it helps sometimes to put it in there so that we know there is no vertical translation. My vertex, because we have vertex form, is 3, 0, and my axis of symmetry is axis of symmetry is x equals 3. Remember, it's an equation of a line. All right, we'll do one more here. Let's look at number 3. Okay, in number 3, notice there's no parentheses squared because when they don't have an H value, they just sort of ignore it. So if you want to rewrite this, we can change it to a Y as well. -0.5, if you want to expand the x squared to become x minus 0 squared, I think that really helps because then you can see the H and the K. It helps when you have to write the vertex. So this parent function is being reflected because of the negative. So the parent graph is reflected over the x-axis. It's compressed vertically because of the 0.5. And it is translated down 1 unit. All right, there we have it. I'm going to save this last example for in class. We can finish that one up while you guys are in class. Okay? I think you got a good idea as to what's going on there. Last part here, they want us to come up with the equation. They give us a graph and we got to come up with the equation. So I know that the equation is y equals a x minus h squared plus k. So I need an a, an h, and a k. I need 3 parts to make sure that I can write my equation. Everything else just stays. I know that h and k represent the vertex. And so my vertex is right here, and I can see that my vertex is 2 to the right and down 3, so 2, -3. So what I can gain from my vertex is that this is my h value, and my k value is -3. So I have h, and I have k. My a value determines the width. There's no actual number here that I can just calculate the width. But what I can do is I can use my graph, and I can use this equation a little differently. So if you notice, we have h, we have k, and we have a whole bunch of x and y's. Remember, x and y represents every ordered pair on this graph. So if I can find one ordered pair to plug in, along with h and k, the only variable left that we can solve for is a. I need to figure out what the value of my a is. So I see a nice ordered pair right here. Okay, you want to look for one that crosses at the crosshairs. I could also use this one over here. So this ordered pair is 4, -1. And so my x value would be 4, my y value would be -1. So I'm actually going to use the equation, plug in x and y, plug in h and k, and solve for a. So my y value is -1, a we don't know, x is 4, h is 2, and my k value is -3. So order of operations, I need to do what's inside the parentheses first. So 4 minus 2 is 2. Do it one thing at a time. Next step is to square the 2. And I'm going to put it out in front of the a. That's how many a's we have. So we have 4 a's minus 3. Add 3 to both sides. I get 2 is equal to 4a. Divide by 4. And that tells me that a is equal to 1/2. That's not my final answer. I needed the a value to complete and answer the question. They want us to write an equation. So now my equation is y equals 1/2. It's opening up. If it was opening down, I'd have to force the negative part. I would actually change my a to a negative, but it's opening up, so I'm going to leave it as 1/2. And then x minus 2 squared minus 3. So we're all done. So we used a point, we found h and k, and then we could find a. All right, so for your lesson summary, just give me the vertex and the equation of the axis of symmetry of that particular quadratic, and then tell me everything you can about the other quadratic here. Okay, and I'm actually going to add something to it. I'm going to make it a -1/3. Let's talk about a -1/3 on the outside there, just to make it a little bit more complicated. Use your mathematical terms: reflection, translation, compressed, and stretched. Good luck.